All right, so in contrast to sequences, we're going to talk about series. And a series is related to sequences, but when I ask you to find the series, we're actually going to find the sum of all the terms of a sequence. Okay? Um, so a sequence just lists out terms. A series actually finds the sum of those terms. Okay, so sigma notation is what we use when I'm asking you to find a series, and sigma notation is the mathematical notation for summation, summation meaning terms added together, and that's represented by the Greek letter sigma. Sigma looks kind of like this. It's actually, just as a side note, sigma is the uppercase letter S in the Greek alphabet. So the lowercase looks like this, I think, and those, it's S for summation, so kind of interesting. So we're going to use the Greek letter sigma when we want to talk about the summation of something, adding something together. The partial sum is when we're asking you to find the sum of a finite number of terms in a series. And then finally, what does finite mean? It means a limited quantity, or the opposite of infinite. So even though a sequence goes on infinitely, sometimes we'll just ask you to find the sum of a finite number of the terms. So we find the first 5 or the first 10 or the first 15 or something like that. So I want to do an example with you. Go ahead and pause this if you need to finish writing these down. Otherwise, I'm going to move on here and show you a quick example that's not in your notes. So let's say we were working with a sequence that maybe started at 1 and then added maybe 3. Every time. Okay, so, and maybe we call this the sequence A sub n. Okay, we use the capital letter A to actually define a sequence. Okay, so then recursively we might say a lowercase a sub n when given the first term a sub n. The lowercase actually just indicates each term in the sequence. The uppercase indicates the whole sequence, or the sequence as a whole. So recursively, this is defined by taking the previous term and adding 3. Okay, so what it might say, we might put in sigma notation, is using the sequence a sub n from n equals 1 to 3. With sigma notation, what this means is we're actually going to find the sum of the first 3 terms from 1 to 3. So 1, 2, 3. So what this means is I'm going to ask you to do 1 plus 4 plus 7, which is 12. Okay? Another way that we might write it is using the explicit formula. So the explicit formula for this is 1 plus 3 times n minus 1, or 3n minus 2 to get you each term. So you might also see it written with the explicit formula. So the first 3 terms of 3n minus 2, meaning we're going to take and plug n in. So we're actually going to do 3 times 1 minus 2 plus, so we did the first for an n of 1, then we're going to do it for an n of 2 and an n of 3. So 3 times 1 minus 2 is 1. 3 times 2 minus 2 is 4. 3 times 3 is 9, minus 2 is 7. So obviously the same thing, just written out explicitly instead of just defined by the terms in the sequence. Okay? So that's kind of how sigma notation works. So giving another example here, the sum of the first 5 terms of a sequence with a of 1 equal 10 and the common difference of 5. So I'm just going to write these out here. So I have the first term as 10, and then my common difference is minus 5, so I'm going to have 5, 0, negative 5, negative 10. So interestingly enough, these first 5 terms, as I'm thinking about adding them together, because maybe we could call this a sub n. So writing in sigma notation, I'm trying to find from 1 to 5 of a sub n. So I'm asking to find 10 plus 5 plus 0 plus negative 5 plus negative 10. And when I think about adding those together, it looks like every number kind of has a counterpart here, so I'm going to actually get a sum of 0 for this one. All right, before class, I want you to write this statement in sigma notation and then evaluate. So the sum of the first 3 terms of a geometric sequence with a sub 1 equals 0 and the ratio being 1/2. Okay? Bring that to class with you tomorrow.